On the morning of March 14, 1879, in the city of Ulm in Germany's Baden-Württemberg region, a quiet yet history-shaping birth took place. Albert Einstein came into the world. At that time, Ulm was not one of Germany's largest cities. With a population of about 30,000, it was a calm, peaceful, and steadily developing industrial town, built along the banks of the Danube River. The city carried both the remnants of the medieval past and the marks of the new industrial revolution. People mostly worked in small shops, apprenticed to craftsmen, or found employment in factories. It was in this modest setting that one of humanity's greatest scientific minds drew his first breath. Though the day seemed ordinary, it marked the beginning of a mind that would one day change the balance of the entire world. Einstein's family was of Jewish origin. However, they were not religious in the traditional sense. For them, modernization, education, and culture were far more important than ritual. This outlook would deeply influence Albert's intellectual world. His father, Hermann Einstein, was a calm and dignified man. As a businessman, he managed small-scale ventures in electrical engineering. His dream was to make the rapidly growing technology of electricity more accessible in Germany. At the time, electricity was still a novelty and far from widespread. Hermann's work was therefore risky, but also innovative. His mother, Pauline Koch Einstein, was cultured and had refined tastes. She was particularly passionate about music, played the piano, and loved classical compositions. Pauline placed great emphasis on her son's education and wanted him to grow up with a balance of art and science. Later in life, Albert would share his mother's love of the piano, and music would become both an intellectual and emotional refuge for him. The family lived at a middle-class standard. They were neither poor nor wealthy, but had enough stability to live comfortably and provide their children with educational opportunities. The Einstein home was simple yet filled with a sense of peace. Books, musical instruments, and business papers surrounded young Albert as he grew. Looking back today, it is remarkable to think that this small city would be the birthplace of a child who would later shatter conventions of physics and uncover some of the universe's deepest mysteries. Yet at that moment, no one could have predicted such a future. To the doctors who held him, Albert was just an ordinary infant. But his very first cries, echoing through Ulm's narrow streets, were in fact a quiet herald of a new age in the history of science. Albert's childhood was at times a source of concern for his family. He began speaking later than most children. While children usually start communicating with words between the ages of 1.5 and 2, Albert did not form proper sentences until the age of 3. Relatives who loved him but observed him with curiosity often asked Hermann and Pauline, "Why hasn't this child started talking yet?" His parents grew anxious at these questions, though deep down they sensed that there was something different about him. In the family's modest homes in Ulm, and later in Munich, this topic came up often. Neighbors wondered aloud, "Is something wrong with the boy?" Some shook their heads quietly, while others tried to comfort the parents with, "Don't worry, he'll start talking in time." Yet as the days, months, and years passed without change, the family could not help but worry. His mother, Pauline, however, noticed something that others overlooked, the focused, searching look in her son's eyes. Everyone could see that he wasn't speaking, but few realized the depth behind his gaze. Pauline sensed that those eyes reflected the workings of a mind far more intense than that of an ordinary child. Some family friends whispered that he might have a mental problem. At the time, medical science knew very little about child psychology, and unusual behavior was often misinterpreted. Quiet children were labeled either shy or slow-witted, while the unique richness of their inner worlds went unseen. In truth, Albert's introverted nature was not a weakness, but a sign of extraordinary mental intensity. Even during those silent early years, Albert observed the world around him with unusual attentiveness. He would watch the steam rising from a pot as his mother cooked, follow with his eyes the flickering light of his father's gas lamp against the wall, and stare in fascination at raindrops sliding down the window pane. Before he learned to think in words, he was already thinking in images, movements, and the patterns of nature itself. Albert delayed speaking. because he preferred thinking over talking. From a very young age, he chose his words so carefully that long silences before forming a sentence became a common occurrence. His quietness demanded a kind of patience that was difficult for the more restless to understand. According to those who knew him, little Albert would not respond immediately to a question. Sometimes he would wait for minutes before finally answering. This trait would later shape his scientific approach as well. Never rushing a thought and never accepting even the smallest detail without questioning it first. This happened often within the family. For example, at the dinner table, someone might ask him something simple like, "Albert, do you like the soup?" The young boy wouldn't answer right away. Instead, he would slowly stir the soup with his spoon, purse his lips slightly, and fix his eyes on the ripples forming in the bowl, as if more interested in the waves than in the question itself. Only after a while, when everyone else had already forgotten the exchange, he would say, "Yes, it's good," for those around him. This behavior seemed unusual, but in truth, his mind was weighing every thought carefully before speaking. To outsiders, this silence sometimes appeared dull or even incomprehensible. In reality, however, it was the first sign of the analytical thinking that was already taking shape in Einstein's young mind. While others wondered, why doesn't he just answer right away? He was silently running each word through his mind over and over, preferring to say nothing rather than risk saying something wrong. This habit would later make him a patient, meticulous researcher, obsessed with details while developing his scientific theories. Years later, his mother Pauline recalled in her memoirs how her son would sit alone for hours, sometimes folding his hands in his lap and staring at the walls. For most people, these moments would have seemed uneventful, but within young Albert's mind, they were turning into invisible storms. He grasped the world around him, not through words, but through images and questions. His eyes would fix on something, his lips unmoving, as if he were silently solving a mathematical problem deep within his thoughts. Pauline said that in those moments, it was as if her son had disappeared into a universe of his own making. He would hold a toy car in his hands for hours, spin it around, set it aside, then pick it up again to study it. But he wasn't simply playing. He was observing its movement, its rolling, its stillness, and questioning in his mind why it behaved the way it did. When neighbors asked Pauline, "Why doesn't your son play outside? Why doesn't he run around with the other children?" she would smile gently. She knew that Albert's games were not played in the streets, but inside his mind. The same misunderstandings continued during Albert's school years. Some teachers mistook his silence for disinterest. One even told his family, "This boy will never amount to anything." In class, while lessons were being taught, Albert would lower his head onto his desk, not to focus on his notebook, but to gaze out the window at the sky. Teachers assumed he wasn't paying attention. "Einstein, you're not listening at all," they would scold. But while staring at the sky, Albert was in fact thinking about how light spread, how clouds moved, and how the world itself worked. For him, lessons often felt too superficial, while his mind was drawn to deeper questions. The silence of young Albert was like the calm surface of a sea brimming with curiosity beneath. Inside, storms of questions were raging, yet he preferred to turn them over quietly in his mind rather than voice them aloud. One of the most striking traits of Albert's childhood was his boundless curiosity. One day, when his father showed him a small compass, it became one of the defining moments of his life. The needle's constant pointing north sparked a profound question in his mind. What is this invisible force? Why does the needle always turn the same way? At such a young age, his search for answers awakened his lifelong fascination with the hidden mysteries of the universe. To him, the compass was not just a simple toy. It was a mysterious key unlocking the secrets of nature. Little Albert held it at different angles, turned it around, shook it, yet the needle always returned to the same direction. The presence of this unseen force both puzzled and fascinated him. On that day, a spark was lit in his mind. The unseen is real, and it can be understood. Even the simplest events in nature captivated him. He could spend long moments watching raindrops slide down a window, light bend through glass, with a shimmering glow of stars in the night sky. What seemed ordinary to others opened doors to profound mysteries for him. Though his silence, introversion, and differences were sometimes misunderstood, they became a source of richness for Albert. While those around him worried about his lack of words, he had taken refuge in something stronger than speech: thought. In his mind, he was constantly creating questions, building what could be called an invisible laboratory of his own. Inside this invisible laboratory, Albert carried out experiments, asked questions, and tried to find answers through imagination. For most children, a toy train was merely an object to play. But for Albert, it raised questions about light, speed, and time. Years later, his famous thought experiments would grow directly out of these childhood habits. And so this silence, this intense inward focus, would remain one of his defining traits throughout life. While others saw his slowness to speak as a flaw, Albert had already discovered the creative power hidden within silence. This quiet child would one day ask the questions and find the answers that would illuminate humanity's understanding of the universe. Albert Einstein's personality and sense of curiosity were shaped by his family's guidance and the influence of his environment. His father, Albert Einstein, opened the doors of the technical world to him. Hermann was involved in numerous projects related to electrical engineering and small machines. Their home was filled with gadgets, electrical devices, wire coils, and experimental tools. From the age of 3 or 4, young Albert was introduced to electric circuits and mechanical instruments. By carefully observing his father's equipment, he began to notice how different parts interacted with one another. According to some accounts, even as a child, he carried out simple experiments with small motors and generators. These early experiences sharpened his powers of observation and analytical thinking, laying the foundation for the endless why and how questions that would define his life. As influential as Hermann's technical interests were, Albert's mother, Pauline Einstein, also left a deep mark on his character. Pauline was a talented pianist and often filled their home with classical music. She taught young Albert to play the violin, introducing him to lessons when he was still just a child. For Albert, the violin became far more than a hobby. It turned into an essential part of his life. During stressful times, moments of confusion, or personal struggles, he often turned to the sound of the violin for comfort. The works of Mozart and Beethoven not only soothed his spirit, but also shaped his mental processes. Some historians have even emphasized the role of music in inspiring Einstein as he envisioned his complex theories. The influence of his family extended beyond technology and music. Hermann and Pauline created an environment that encouraged Albert to ask questions and explore. His father's scientific mindset, combined with his mother's artistic sensibility, nurtured him into a thinker who was both rational and creative. It is no exaggeration to say that his future achievements were deeply rooted in the experiments he observed at home, the melodies he grew up with, and the loving yet intellectually stimulating atmosphere his parents provided. In short, Albert Einstein's early curiosity, his drive to explore, and his love for music, combined with his family's influence, lifted him from an ordinary childhood onto the path toward genius. His scientific fascination, sparked by his father's technical pursuits, merged with his mother's passion for music, giving him a balanced mind that straddled both science and art. The violin was not only a source of comfort, but also an instrument of inspiration through which he organized his thoughts and developed new ideas. Einstein's school years, however, were not always easy. His personality and style of learning did not fit neatly into the rigid framework of traditional education. Teachers recognized that he was different, but most misinterpreted his questioning nature, his constant why and how. In the classroom, rather than being seen as intellectual curiosity, was sometimes viewed as a problem of discipline. One teacher went so far as to tell him, "You will never amount to anything." Though harsh and discouraging, such words sparked both defiance and deeper curiosity within young Albert. For a mind like his, creative and independent, the school system was often inadequate. Textbooks and curricula could not keep up with his questions. His thirst for knowledge had already outgrown the boundaries of the classroom. At home and in libraries, He began to read on his own, diving into advanced works of mathematics, physics, and philosophy. It is known that he studied Cauchy's treatises on differential and integral calculus, Gauss's theories, and even Kant's philosophical writings at an unusually young age. For Albert, learning was never about obligation or academic success. It was as vital as breathing. Ordinary homework and school exams rarely held his interest. Instead, he pursued whatever satisfied his own curiosity. Solving problems in mathematics and physics was like play for him. The excitement he felt after finding a solution was unmatched by anything else. This self-driven discipline also strengthened his ability to think independently. Through self-study and mental experiments, he developed an extraordinary talent for grasping abstract concepts. This process laid the foundation for the great questions he would later pose about the workings of the universe. Albert was not just a boy memorizing formulas. He was a seeker, striving to uncover the very logic of existence. In many ways, the difficulties he faced in school became a crucial force in shaping his character and passion for learning. Education, for him, was not about pressure or obligation, but about curiosity, imagination, and self-expression. Even if most of his teachers failed to understand him, Albert carved his own path, freeing his mind and taking his first steps toward becoming the genius the world would one day know. By his teenage years, mathematics and physics had become more than subjects. They were a way of life. To him, formulas were not just numbers and symbols. In the abstract world of equations, he glimpsed the order of the universe, the hidden workings of nature, and the intimate link between matter and energy. What had begun as childhood curiosity now blossomed into a focused scientific passion. While still in high school, he was able to solve differential equations, integrals, and advanced mathematical problems on his own. Some sources note that he studied university-level mathematics during these years, refusing to be limited to standard school books. For Einstein, mathematics was like a game. Solving a problem was not a task, but an adventure of discovery. He would invent new equations, challenge the logic of formulas, and try to connect abstract concepts with real-world phenomena. Albert's mind was always preoccupied with great questions. What is light? If I were to ride on a beam of light, what would I see? Is empty space truly empty, or is it filled with unseen laws? At the time, these might have seemed like nothing more than a child's fantasies. But in his mind, they combined with deep logic and a coherent process of inquiry. Einstein sought to understand not only what could be seen, but also what lay hidden beyond sight. The scenarios and questions he created in his imagination became the cornerstone of his scientific method. His passion for mathematics and physics was the clearest trait that set him apart from an ordinary student. He asked constant questions in class, rarely content with the answers given by his teachers, always searching for his own explanations through logic and observation. Sometimes teachers found his approach too challenging, even disruptive, but Albert chose to follow his curiosity rather than submit to external expectations or the limits of conventional education. This discipline of curiosity and self-learning, developed so early, also sharpened a capacity for abstract thought. In his mind, he combined mathematical formulas with physical laws, mentally recreating the processes of nature to understand why and how they occurred. This very process laid the groundwork for the thought experiments that would later allow him to reshape modern physics with revolutionary theories. For Albert, mathematics and physics were more than tools of learning. They became the language through which he understood the universe, the means by which he expressed his thoughts, and the passion that guided his life. Every question, every problem, every daydream opened a new door to the mysteries of existence. This intense curiosity and imagination, nurtured since childhood, would one day evolve into groundbreaking theories that forever changed humanity's view of the cosmos. For young Albert Einstein, mathematics and physics were not simply school subjects. They were a language to understand the universe, a tool to express his ideas, and a passion that shaped his destiny. This passion planted the very first seeds of scientific achievements that would unlock the fundamental laws of nature. From an early age, Albert Einstein developed a habit of conducting thought experiments in his mind, going far beyond ordinary experiments and laboratory settings. Physics books and mathematical formulas were not just abstract knowledge to him. He visualized them, using his imagination to test different scenarios. This practice later became one of the cornerstones of his scientific method and laid the groundwork for the revolutionary ideas that would reshape modern physics. One day, young Albert imagined himself riding along a beam of light. If he moved at the same speed as light, what would he see? This seemingly simple question grew into a monumental problem in his mind. Combining observation with imagination, Einstein began to explore the nature of light and the relationship between space and time. That moment marked the beginning of a thought process that reached far beyond a child's ordinary daydreams. It was the first spark of mind questioning the fundamental laws of the universe. His thought experiments became a unique arena where logical reasoning and creativity merged. Without the need for a physical laboratory, Albert could model complex systems in his mind and test scenarios that seem impossible in reality. For example, he would picture an observer moving at the speed of light, the world inside a moving train, or a point on a spinning wheel, all in an effort to uncover how nature truly worked. Each of these mental experiments pushed him further, opening new doors towards solving the mysteries of the universe. This approach set Einstein apart from most of his peers. While other students carried out only the experiments assigned by teachers, Albert created his own in his imagination, blending creativity with the rules of mathematics and physics. This process not only enhanced his mental flexibility, but also strengthened his ability to make abstract concepts tangible. Thought experiments would later become the foundation for his special and general theories of relativity. These mental explorations also shaped his problem-solving style. Albert did not restrict himself to what could be seen. He explored the unseen possibilities as well. This unique perspective enabled him to probe the hidden laws of the cosmos, the nature of space and time, and the behavior of light. For him, imagination was inseparable from science. Dreaming, thinking, and questioning formed one unified process. In short, Einstein's thought experiments were far more than the playful fantasies of a child. They were a tool that defined his inner world, a method that guided his creativity, and a bridge toward understanding the universe. Through these mental games, young Albert planted the seeds of the groundbreaking theories that would one day revolutionize physics. Thus, Einstein's childhood and youth unfolded in silence, yet brimmed with deep curiosity, imagination, and intense inner reflection. To his friends, he often appeared shy, withdrawn, and quiet, more inclined to think alone than to join games. But this silence masked a storm of mental activity beneath the surface. From an early age, Albert cultivated a habit of observing the world, recognizing patterns in nature, and carefully testing questions within his own mind. What looked like solitude was, in reality, a laboratory of thought where curiosity thrived. His teachers, however, often misunderstood this unusual behavior. His relentless questions, boundless imagination, and deep way of thinking were sometimes seen as disruptive. Many dismissed him as overly dreamy, criticizing him for not following a routine flow of lessons. Yet such remarks could not restrain his independent mind. Instead of being confined by repetition and rigid curricula, Albert created his own mental experiments, taking his thoughts far beyond the classroom. Albert's imagination was no ordinary child's play. His dreams reflected the early stirrings of a mind wrestling with the universe's most profound mysteries: the nature of light, the relativity of space and time, the hidden laws of the cosmos, and the relationship between mass and energy. All these ideas took shape within his silent world, maturing into the foundations of theories that would later transform physics itself. Silence gave him the gift of sharper observation. Every detail, every glimmer of light, every mathematical concept carried universal meaning in his eyes. From a flight of birds to the shifting of shadows, from a flow of water to the sparkle of stars, every natural phenomenon became both a question and a field of discovery. His silence was a laboratory of thought where ideas grew, theories matured, and dreams prepared to take form. This quiet introspection also strengthened his mental resilience and focus. Though socially reserved, Albert could channel his full attention into subjects that fascinated him, spending endless hours solving mathematical equations, modeling physical laws, and testing his imagination through mental experiments. This discipline sharpened his problem-solving skills and laid the foundation for his groundbreaking theories of relativity. A small, quiet, withdrawn child. Yet his silence became the soil in which genius took root, the space where imagination was nurtured and expanded. Every mental game, every why and how, carried him further on a path toward understanding the universe. Through young Albert's silent window, one can see how powerful a child's imagination can be, how genius first begins to blossom, and how the boundaries of human knowledge can be transformed. Albert Einstein's childhood and youth were a fusion of silence and boundless curiosity. His quietness was not merely a character trait. It was the purest reflection of his mental strength, imagination, and passion for discovery. This silence and inward focus lifted him beyond an ordinary childhood, preparing him to become one of the most creative and influential scientists in human history. In 1896, Einstein was admitted to the Zurich Polytechnic School. This acceptance marked both a turning point and a new beginning in his life. Zurich Polytechnic was one of the most prestigious technical and scientific schools of its time, offering a multidisciplinary education in engineering and the natural sciences. For Albert, this environment was not only exciting but also a great test, as the school was known for its strict discipline, demanding curriculum and authoritarian professors. The traditional educational system at the school did not always suit Einstein's independent way of thinking. In lectures, he often questioned established theories and was never satisfied with the answers provided by his professors. For him, knowledge was not a list to be memorized, but something to be tested through logic, experiments, and imagination. Frequently, the standard solutions given in class only raised more questions in his mind, and he sought answers in his own way. Some professors did not understand his unconventional approach and often saw it as a problem of discipline. Yet Albert ignored the boundaries of classroom and curriculum, continuing to expand his mental laboratory, his thoughts, and his imagination. Einstein was devoted to learning not only in class, but also in his free time. He studied physics and mathematics in depth on his own, filling gaps he found in the curriculum. He derived his own formulas, uncovered connections absent from textbooks, and tested abstract concepts through concrete examples in his mind. This process strengthened both his analytical ability and his capacity for creative thought. Constantly mentally active, Albert tried to understand the fundamental laws of the universe through models he built in his mind, beyond laboratory experiments and observations. His limited social circle did not leave him lonely. Rather, it allowed him to focus on his thoughts, mental experiments, and imagination. Even though he did not form very close friendships, the ideas he developed and scenarios he envisioned in his mind gave him a boundless space for freedom. Albert saw solitude not as a deficiency, but as an opportunity. Silence and isolation fed his creativity, nurtured his independence of thought, and helped him discipline and deepen his ideas. For Einstein, learning was much more than memorizing formulas. It was about understanding how the universe works, grasping the fundamental laws of nature, and developing new theories in his mental laboratory. He questioned every concept taught in class, tested in his mind, and sought to confirm it through his own reasoning. Applying what he learned, blending it with logic and imagination, became his way of life. His years at Zurich Polytechnic were not just those of a student, but a researcher and an independent thinker dedicated to discovering the mysteries of a universe. Looking more deeply, these years functioned as a laboratory in which Einstein developed his intellectual freedom, patience, analytical ability, and imagination all at once. Every lecture, every debate, every search for solutions became an experimental ground in his mind, laying the foundations for theories he would later create. His time at Zurich Polytechnic was not only about gaining academic knowledge. It was a period in which Albert Einstein's scientific genius and independent thinking took shape, when the first seeds of ideas that would change human history began to sprout. In short, Albert Einstein's university years, shaped by difficulties, limited social relationships, and a rigid academic structure, were nevertheless the period when he found his own path, developed his unique scientific outlook, and took his first steps toward unlocking the secrets of the universe. These years were an exceptional intellectual and creative process, laying the groundwork for the discoveries that would one day leave an indelible mark on human history. After completing university successfully, Albert Einstein began working as a technical expert at the Swiss Patent Office in 1902. At first glance, this job may have seemed like an ordinary bureaucratic position for a physicist. But for Einstein, it provided a working environment very different from academic laboratories, yet just as inspiring. The Patent Office was a place where new inventions, electrical devices, and mechanical tools were reviewed. Einstein spent his days analyzing the design, operation, and logic of various devices, carefully examining the technical details of patent applications. For him, this was more than routine work. It was a perfect mental exercise for understanding complex physical processes. Working at the Patent Office gave Einstein extraordinary mental discipline. Each application required him to solve the design logic of a device, evaluate its functionality, and identify possible flaws. This honed his abstract thinking ability and later allowed him to construct complex theories in his mind. Simple-looking mechanical and electrical mechanisms turned into larger conceptual experiments in his imagination. While analyzing these devices, he also contemplated their relation to the fundamental laws of physics. For instance, while examining an electromagnetic device, he built mental models about electricity and magnetism and connected them with mathematical formulas. This ability to unite abstract physical concepts with concrete realities was strengthened in these years. The Patent Office also helped Einstein develop his working discipline. The daily routine of reviewing and reporting applications taught him time management and focus. Yet his mind constantly wandered beyond patent files. The devices and mechanisms he observed at work came alive in his imagination as abstract experiments and mathematical simulations. These mental experiments were no different from those in a physical laboratory. Through scenarios constructed in his mind, Einstein tested the movement of light, the relativity of time and space, and the nature of energy. The year 1905 would go down in history as Einstein's Annus Mirabilis, the miracle year. In that year, he published 4 papers that laid the foundations of modern physics. One was about the quantum nature of light. Another explained Brownian motion. The third introduced the theory of special relativity. And the fourth contained the famous equation, E equals mc squared, expressing the relationship between energy and mass. These works were the result of years of mental experimentation, mathematical reasoning, and careful observation. The Patent Office had become his quiet laboratory, a place where he matured his ideas and tested the laws of the universe in his mind. His years at the Patent Office gave Einstein not only the chance to shape his scientific genius, but also the freedom to think independently from academia. Free from the constraints of exams, professors, and rigid programs, he was able to produce ideas freely. Every new device he reviewed, every mechanical or electrical mechanism, planted new questions in his mind, and these questions became the seeds of his future theories. The seemingly routine office environment served as a ground where his thinking deepened, his problem-solving skills matured, and his creative intellect reached its peak. Albert Einstein's time at the Patent Office was far more than just a job. It was a critical preparatory phase in which he developed scientific thought, mental experimentation, and analytical skill. The discipline, observational ability, and abstract thinking capacity he gained there formed the foundation for his revolutionary theories of the 20th century. For Einstein, the Patent Office was much more than a means of livelihood. It was a quiet laboratory that nurtured his intellectual freedom, creativity, and scientific curiosity, and where the first seeds of ideas that would shape human history began to grow. The year 1905 was a true turning point in both Albert Einstein's life and in the world of science. It became known as Annus Mirabilis, the miracle year, and it not only transformed Einstein's career, but also reshaped the very foundations of modern physics. At the time, Einstein was working as a technical expert at the Swiss Patent Office. From the outside, his daily life might look routine and ordinary, yet within the quiet, disciplined flow of the office, His mind was constantly alive. The inventions, electrical devices, mechanical systems, and innovative technologies he examined there sparked new questions and mental experiments in his imagination. These routine but observation-rich days did more than provide him with a job. They gave him the freedom and time he needed to develop his groundbreaking theories. Throughout 1905, Einstein published 4 papers that shook the scientific world. They explored the nature of light, atomic motion, the relationship between energy and mass, and the theory of special relativity. Each one laid a cornerstone of modern physics, profoundly challenging the scientific paradigm of the time. These works were not only the product of his academic knowledge, but also of his imagination, analytical brilliance, and independence of thought. When first published, the papers made an enormous impact and propelled Einstein far beyond his era. His theories provided a foundation for scientific research, not only of the present, but also of the centuries to come. Among these papers, the special theory of relativity was one of the most revolutionary. The theory showed that time and space are not absolute, but depend on the motion of the observer. This radically challenged the Newtonian view of absolute time and space that had dominated physics for centuries. Since childhood, Einstein had questioned the nature of light and the perspectives of different observers through thought experiments. Over years, these mental explorations, combined with mathematical work and conceptual modeling, culminated in this groundbreaking theory. Special relativity was not merely a theoretical paper. It was a paradigm shift that transformed humanity's understanding of the universe. Einstein redefined the relationship between energy and mass, formulating the famous equation E equals mc squared, which revealed that energy is directly tied to the very essence of matter. This equation will become the foundation for modern technology, nuclear energy, GPS systems, and space exploration. By redefining the concept of time and space, special relativity enabled humanity to understand how every observer's perspective interacts with the universal laws of nature. In short, 1905 was a year when Einstein's quiet observation-filled work and mental experiments found their way into the scientific world, laying the foundations of modern physics. The Annus Mirabilis was not just an academic success. It was a revolution born of imagination and analytical thought, one that forever changed humanity's perspective on the universe. That year transformed Einstein into more than a scientist. It made him a pioneer who reshaped the very way humankind comprehends reality. Albert Einstein's scientific genius was born out of the thought experiments he developed in his childhood and youth. His scientific method was not limited to experiments performed in laboratories. Instead, he tested the universe in his mind, imagining scenarios that seemed impossible. This habit sharpened his capacity for abstract thought to an extraordinary degree and later became the very method through which he laid the foundations of modern physics. His most famous thought experiment began with a childhood fantasy, riding alongside a beam of light. If he were to travel at the same speed as a light ray, what would he see? From a perspective of a light beam, how would the universe appear? These questions created an endless chain of thought that accompanied him throughout his life. Though impossible to confirm experimentally at the time, such mental scenarios allowed Einstein to merge imagination with mathematics and turn abstract concepts into something concrete. His years at the patent office provided the perfect setting for these mental experiments. While reviewing different devices and evaluating patent applications, he carried out experiments in his mind. Simple mechanical systems or electrical devices became laboratories for testing the laws of nature in his imagination. Each device raised new questions about motion, energy transfer, or electromagnetic interaction, and Einstein systematically tested them in his mental laboratory. These thought experiments gave Einstein the ability to link abstract concepts with concrete phenomena. Complex ideas, such as the nature of light, the relativity of time, and the variability of space, became, in his mind, the equivalent of laboratory experiments. His method diverged from classical experimental physics, transcending the limits of physical experiments and testing the fundamental laws of the universe through mental modeling. This process laid the foundation for revolutionary theories, such as special relativity and later general relativity. Einstein's thought experiments strengthened not only his grasp of physical concepts, but also his mathematical reasoning and logical deduction. By fusing imagination with mathematics, he could solve complex equations and theoretical scenarios in his head, predicting possible outcomes long before they could be tested. This ability allowed him to go far beyond ordinary observation, because Einstein could comprehend the universe not only by observing it, but also by recreating it within his mind. These thought experiments formed the foundation of modern physics' revolutionary theories. They redefined the scientific method, introducing a unique approach born from the fusion of imagination and analytical thought. In his pursuit of light, Einstein created his own mental laboratory to unravel the secrets of time, space, and energy. This method, the most characteristic feature of his scientific genius, opened the way for discoveries that would forever shape human history. Albert Einstein's special theory of relativity, developed in 1905, went down in history as a revolutionary work that completely transformed humanity's understanding of time and space. This theory not only redefined the interpretation of physical phenomena, but also reshaped human perception of the very fabric of the universe. Before Einstein, physics was grounded in Newton's concepts of absolute time and absolute space. Time was believed to flow at the same rate for everyone, and space was seen as an unchanging, universal stage. This worldview had formed the foundation of scientific thought for centuries and was widely accepted without question by most scientists. From an early age, however, Einstein challenged his perspective through thought experiments, and his years of observation at the Patent Office allowed him to support these challenges with solid mathematical foundations. According to special relativity, time and space are not absolute. They vary depending on the motion of the observer. A stationary observer and one moving near the speed of light experience the passage of time differently. This was a direct challenge to the core assumptions of Newtonian physics. For instance, an observer moving at the speed of light would perceive time as slowing down and distances as contracting. While this seemed paradoxical at first glance, Einstein's rigorous mathematical calculations and later experimental confirmations proved it true. To develop this theory, Einstein relied on thought experiments, turning abstract ideas into concrete scenarios. The mechanical and electrical devices he examined at the Patent Office became, in his imagination, experimental laboratories. Each machine and each piece of technology offered an opportunity to test the behavior of motion, energy, and light. Einstein combined these observations with mathematical modeling, grounding his abstract ideas in solid science. This process not only generated theoretical predictions, but also extended the scientific method into a mental laboratory. Special relativity was more than just a theoretical innovation. It was a fundamental revolution in the way the universe was understood. Time and space were no longer fixed backdrops, but dynamic structures interacting with energy and motion. This new perspective laid the foundation for countless applications, from modern technology to space exploration. For example, without relativistic time corrections, GPS satellites would accumulate significant errors, rendering them useless. This demonstrates that Einstein's theory is not only of academic importance, but also vital for everyday life and technology. Einstein's unique combination of mathematical genius and imagination brought about an unprecedented paradigm shift in physics. The relativity of time and the flexibility of space did not merely provide new formulas. They fundamentally transformed humanity's perception of the cosmos, connecting individual experiences with universal laws. Thanks to the analytical skills he developed in the Patent Office, his thought experiments, and his keen observational abilities, Einstein was able to make this revolution possible both theoretically and conceptually. The relativity of time and space, introduced by special relativity, stood out as a true revolution that reshaped humanity's view of the universe. Einstein fused his childhood curiosity and imagination with mathematical rigor to build a radical understanding of how the universe works. This understanding left a lasting legacy, influencing not only science but also technology, engineering, and daily life. The routine yet observation-rich days at the patent office pushed his creativity and intellectual capacity to new heights, enabling him to lay the foundations of modern physics. In short, special relativity and the relativity of time and space were not merely scientific achievements. They were revolutions that tested the limits of the human mind, born from the fusion of imagination and analytical thought. In his mental laboratory, Einstein developed a vision that transcended classical physics and forever altered humanity's perception of the universe. When Albert Einstein published the special theory of relativity in 1905, it sent shockwaves through the scientific community, sparking both astonishment and debate. The theory fundamentally questioned the assumptions of Newtonian physics, rejecting the notion of absolute time and space. Such a radical idea was initially difficult for many academics and physicists to grasp. For scientists who had long accepted these concepts as unshakable truths, Einstein's claims seemed paradoxical and unsettling. Yet Einstein distinguished himself not only with bold ideas, but also with the meticulous mathematical calculations that supported them. At first, special relativity was seen as purely theoretical, but Einstein's equations and predictions quickly became the subject of lively discussion among physicists. The initial reactions were largely skeptical. Some scholars resisted the notion that time and space were relative, and the idea that the speed of light was constant for all observers clashed directly with classical physics. Nevertheless, Einstein's logical reasoning and experimentally testable predictions gradually overcame these doubts. The process of the theory's acceptance reflected Einstein's brilliance and passion for science. His thought experiments and analytical skills, honed during his years at the patent office, enabled him to construct accurate and elegant equations. These equations provided not just a theoretical framework, but also demonstrated the consistency of universal laws with observable reality. As experimental physicists began to test Einstein's predictions in laboratories, the validity of the theory became clearer, and it started to gain acceptance within the scientific community. The impact of special relativity soon spread beyond academia, deeply influencing modern technology and engineering. Relativistic corrections in GPS systems, nuclear energy production, and the calculation of near light speed motions would all be impossible without Einstein's theory. This highlighted the revolutionary influence of the theory in both theoretical and applied science. Einstein's quiet, observant, and analytical working style played a critical role in the acceptance of his theory. His years at the patent office allowed him to refine his thought experiments systematically. His imagination and mathematical ability became forces strong enough to change the course of scientific paradigms. This process transformed Einstein from a brilliant scientist into a pioneer who fundamentally altered humanity's understanding of a universe. The initial responses to special relativity were marked by surprise and skepticism, but its mathematical rigor, experimental verifiability, and universal applicability soon secured its place as one of the most important and revolutionary works in the history of science. Through intellectual freedom, thought experiments, and analytical brilliance, Einstein laid the foundation of modern physics and forever changed humanity's view of the cosmos. Albert Einstein's years at the Swiss Patent Office between 1902 and 1909 played a vital role in shaping his scientific genius. What many saw as ordinary, repetitive work was for Einstein not just a means of livelihood, but also a mental laboratory where he nurtured his creative and analytical thinking. His daily task consisted of reviewing inventions and patent applications. Yet within these seemingly mundane duties, Einstein discovered unique opportunities to question the fundamental laws of the universe. At the patent office, Einstein's observational skills and analytical intelligence were constantly stimulated. Electrical devices, mechanical systems, and new technological inventions became, in his imagination, experimental models. When examining an electrical circuit, Einstein was not only analyzing how the device functioned, he was also mentally testing the behavior of energy, motion, and light. This process allowed him to conduct abstract and complex experiments without the need for a traditional laboratory. The routine nature of office work provided Einstein with a rare kind of intellectual freedom. Limited responsibilities and repetitive tasks open up vast mental space, giving his imagination free rein. During these years, through thought experiments, he systematically tested fundamental concepts such as the nature of light, the relativity of time, and the flexibility of space. For Einstein, the patent office became a silent laboratory, a place where observation and abstract modeling replaced physical experiments, laying the foundation for groundbreaking discoveries. Einstein did not use his observations merely to satisfy personal curiosity. He translated them into mathematical formulas with remarkable precision. This approach was the essential mechanism that enabled him to develop the special theory of relativity. By combining thought experiments with rigorous mathematics, he created a revolutionary framework that transcended classical physics. The patent office thus became the strategic environment where Einstein's ideas could grow freely, nurturing the development of his scientific genius. Moreover, this work environment instilled in Einstein a sense of discipline and methodical practice. Each patent application required careful review, critical analysis, and logical reasoning, skills that became crucial in his scientific endeavors. The patent office provided him with a space where both analytical and creative thinking could coexist, ensuring that his theories, formulas, and thought experiments rested on firm scientific foundations. The Swiss Patent Office functioned as an invisible yet powerful laboratory in Einstein's scientific journey. The routine work enhanced his intellectual capacity and creativity, enabling him to merge imagination with analytical precision. This unique environment paved the way for his revolutionary theories in modern physics. Quiet, disciplined, and intellectually stimulating, the patent office was a platform that made both special relativity and his later scientific achievements possible. When Einstein introduced the special theory of relativity in 1905, it was not only a milestone in academia, but also a revolution that reshaped humanity's understanding of the universe and transformed technological applications. Concepts such as the relativity of time and space, the relationship between energy and mass, and the constancy of the speed of light ushered in a new era in theoretical physics. Yet Einstein's genius lay not just in deriving these ideas mathematically, but also in foreseeing their tangible impact on daily life and technology. One of the most striking effects of special relativity lies in its technological applications. For example, GPS satellites orbiting Earth move at high speeds, which causes time to flow differently for them compared to observers on the ground. Without relativistic corrections, these time discrepancies would lead to significant errors in positioning. In other words, the navigation systems we use daily rely directly on Einstein's predictions. Similarly, nuclear energy production and particle physics experiments depend on the relationship between energy and mass, encapsulated in Einstein's famous formula E equals mc squared, which emerged from special relativity. The theory also brought about a paradigm shift in science. Newton's notion of absolute time and space gave way to a vision of the universe as dependent on the observer. By showing that time and space are flexible, Einstein demonstrated that universal laws are experienced differently depending on an observer's position and motion. This revolutionary perspective affected not only physicists but also engineers, astronomers, technology developers, and ultimately the everyday user. The universal impact of special relativity stemmed from its dual nature, uniting both theoretical and practical dimensions. Through thought experiments, his analytical skills sharpened at the patent office, and his extraordinary mathematical insight, Einstein developed a theory that proved valid in both abstract reasoning and practical application. His mental experiments and equations provided a radical new understanding of how the universe works. In this way, special relativity became more than an academic triumph. It was a legacy that reshaped human perception of the cosmos and revolutionized technology. The theory also expanded the boundaries of scientific thought. Physicists could no longer confine their work to the classical paradigm. They now had to consider perspectives of different observers and the universal behavior of light. This new outlook laid the foundations of modern physics and opened the door to subsequent revolutions, such as quantum mechanics and general relativity. Special relativity, born from Einstein's imagination, thought experiments, and mathematical brilliance, created lasting effects in both science and everyday life. By revealing the relativity of time and space, it deepened our understanding of the universe and became the cornerstone of modern technology, space exploration, communication, and navigation. Einstein's revolutionary insight lives on as a legacy that forever changed humanity's view of the cosmos. The year 1915 is considered a turning point in Albert Einstein's life and in the history of modern science. It was the year he completed the general theory of relativity. Building on his earlier work, particularly the special theory of relativity published in 1905, Einstein realized that the universe was far more complex and dynamic than previously imagined. Special relativity applied only to observers moving at constant speeds, based on the constancy of light and the relativity of time. However, Einstein recognized that the universe could not be fully understood without accounting for the curvature of space-time caused by mass and energy. This insight guided him toward the development of general relativity. For centuries, Newtonian gravity had served as a cornerstone of scientific understanding. According to Newton, masses attract each other directly, and this gravitational force operates independently of space and time. Einstein proposed a far more radical idea. Mass curves the fabric of space-time, creating the effect we perceive as gravity. The mass of a planet or star bends the surrounding space-time, guiding the motion of other objects. This concept was revolutionary not only in physics and astronomy, but also in humanity's understanding of the cosmos. Developing general relativity required years of intense mathematical and intellectual effort. Differential geometry and tensor calculus formed the theory's mathematical foundation. Einstein worked tirelessly for days and even weeks, testing each step meticulously to ensure that the theory was both mathematically consistent and physically accurate. This process revealed his extraordinary talent, not just as a theorist, but also as a mathematical physicist. General relativity was not merely a scientific achievement. It represented a cognitive revolution. The relativity of time and space now described a flexible structure shaped by mass and energy. This framework explained phenomena not only on a laboratory scale, but also at cosmic scales. For instance, the bending of starlight by the sun, observed during the 1919 solar eclipse, confirmed Einstein's predictions, transforming his theory from a theoretical abstraction into an observable scientific reality that captivated the world. The theory fundamentally transformed humanity's ability to understand the universe. Astronomers could now explain the expansion of the universe, the formation of black holes, the motion of galaxies, and even the cosmic microwave background radiation using Einstein's equations. His imagination, thought experiments, and mathematical prowess provided not just a formula, but a revolutionary framework for interpreting the cosmos. General relativity triggered a paradigm shift in science, laying the foundation for modern physics. Moreover, general relativity expanded the boundaries of scientific thinking. Physicists were no longer confined to classical paradigms. They had to consider perspectives of different observers and the universal behavior of light. This shift paved the way for later breakthroughs in quantum physics and cosmology. With this theory, Einstein demonstrated the extraordinary potential of the human mind to conceptualize abstract ideas and understand universal laws. Completed in 1915, general relativity represents the pinnacle of Einstein's genius, a masterpiece that fundamentally changed how we perceive the structure of the universe, gravity, and the dynamic nature of space-time. Years of observation, experiment, and mathematical calculation culminated in a novel perspective that deepened humanity's understanding of the cosmos. The theory left a lasting legacy, influencing not only science but also philosophy, technology, and cosmological thought. Einstein's general relativity did more than revolutionize our understanding of the universe. It provided a fundamental framework for exploring some of the cosmos' darkest and most mysterious structures, black holes. Published in 1915, the theory posited that mass curves space-time to produce gravity. This concept offers scientific foundation for understanding the collapse of stars and the influence of extremely dense masses on cosmic motion. Supported by rigorous mathematical equations, The theory enabled the modeling of even the universe's most complex phenomena. During Einstein's lifetime, black holes were not observed directly, yet the theoretical predictions of space-time curvature made it possible to calculate the effects of these dense objects. Initially, Einstein was skeptical about the physical existence of black holes. Nonetheless, his equations were expanded by other physicists, and from the 1960s onward, astronomical observations confirmed the accuracy of his predictions. Effects such as light bending near black holes, time dilation, and the flow of matter became phenomena explainable through general relativity. General relativity also offered a unique tool for understanding the structure and dynamics of the universe. The expansion of the cosmos, the motion of galaxies, and the distribution of mass could all be mathematically modeled using Einstein's equations. This allowed humanity to interpret the universe not only through observation, but also through theoretical and conceptual frameworks. The universe became more predictable and comprehensible, and stars, galaxies, and even the cosmic microwave background radiation could be studied with this new perspective. Einstein's contributions went beyond theoretical physics, laying the groundwork for modern astronomy and cosmology. The special and general relativity theories explain the bending of light under gravity, the slowing of time near massive objects, and the formation of black holes, inaugurating a new era of scientific discovery. These theories have been verified not only in laboratories, but also at the universe's most extreme scales. Einstein's genius was not limited to producing formulas. His imagination, thought experiments, and mathematical abilities fundamentally transformed humanity's way of exploring the cosmos. Black holes and cosmic mysteries were first proposed theoretically and later confirmed through observation. This process established Einstein not just as a scientist, but as a pioneer who reshaped our perception of the universe. The general theory of relativity and Einstein's subsequent contributions form the foundation of modern physics and astrophysics. The behavior of black holes, the motion of galaxies, and the expansion of the universe became comprehensible and predictable. Observational techniques, including telescopic surveys, radio astronomy, and space exploration, further validated the theory, enabling humanity to access the deepest and most enigmatic secrets of the cosmos. Einstein's general relativity, supported by his thought experiments and mathematical brilliance, provided humanity with a fundamental understanding of the universe's darkest and most complex phenomena. Modern astrophysics and cosmology have advanced thanks to his theories, and his scientific legacy continues to guide our cosmic exploration, forever transforming the way we perceive the universe. Albert Einstein went down in history not only as a scientist, but as a pioneer who fundamentally transformed humanity's understanding of the universe. His work marked a radical turning point in the history of physics and cosmology, developing theories that transcended the limits of classical Newtonian physics and laying the foundations of modern physics. Einstein's genius was a unique combination of mathematical intellect, imagination, and curiosity, three elements that enabled him to develop both the special and general theories of relativity. These theories created profound changes not only within academic circles, but also in the way humanity perceives the cosmos. Einstein's scientific legacy began by pushing the boundaries of theoretical physics. Rather than treating time and space as absolute concepts, he defined them as flexible structures dependent on the observer. This revolutionary approach deeply influenced the way the human mind conceptualizes the universe. His ideas, which linked time, speed, and mass, allowed scientists not only to observe the cosmos, but also to understand it more comprehensively through mathematical models and experiments. Einstein's contributions were critical in the development of quantum physics and cosmology, providing the foundation for subsequent generations of physicists to shape modern conceptions of the universe. Einstein's influence extended far beyond theoretical physics. His work had tangible effects on everyday life and technology. For example, time corrections in GPS satellites would be impossible without Einstein's special and general relativity theories. Global positioning systems must account for the differing passage of time as satellites orbit Earth at high speeds to calculate accurate positions. Nuclear energy production, particle accelerators, and modern communication technologies are also directly influenced by Einstein's theories. In this way, his legacy became not just an academic achievement, but a transformative force in everyday life and modern technology. In the fields of cosmology and astrophysics, Einstein's contributions revolutionized the understanding of the universe's structure. Phenomena such as the formation of black holes, the motion of galaxies, the expansion of the universe, and the bending of light under gravity became explainable through his theories. Einstein led humanity in interpreting the universe's most complex and mysterious processes using mathematical and conceptual frameworks. The equations and concepts he developed proved valid not only in academic contexts, but also in space research, telescope observations, and radio astronomy, demonstrating the breadth and impact of his scientific legacy. Einstein's genius went beyond producing formulas. His imagination, thought experiments, and analytical skill fundamentally transformed the way humanity explores the cosmos. Black holes and the mysteries of the universe were first predicted theoretically and later confirmed through observation. Einstein did not simply introduce new equations to the scientific community. He provided a revolutionary framework for understanding the cosmos. Thanks to his work, humanity could develop a systematic and methodical approach to unraveling cosmic secrets. Einstein's legacy forms the cornerstone of modern physics and astrophysics. The behavior of black holes, the motion of galaxies, and the expansion of the universe became understandable and predictable through his theories. His formulas underpinned scientific research, space exploration, and technological advancement. Einstein's ideas have not only influenced the past, but also serve as a roadmap guiding future scientific discoveries. Moreover, Einstein became a symbol of the power of curiosity and inquiry, inspiring future generations. The thought experiments and visions he cultivated from a young age evolved into the revolutionary theories of modern physics. Today, his legacy guides scientists, combining creative thinking and analytical rigor in the ongoing quest to unlock the universe's secrets. Albert Einstein's legacy is more than a collection of scientific theories. His imagination, thought experiments, and the insights he provided humanity form the foundation of modern physics and our understanding of the cosmos. Einstein went down in history not only as a pioneer of his own era, but as a figure whose work continues to shape the scientific perspective of future generations. The journey to understand the universe was forever illuminated by his genius, and humanity continues to explore the cosmos, guided by the legacy he left behind.